I trust you can all hear me without a microphone, because I need to use the mouse, so I can really hold the mic. So yeah, my name is Ciro Continisio. I'm a technical evangelist in Unity Technologies. I work in Brighton, in the UK. Technical evangelist means that I usually go to conferences to show Unity, to explain about new features, and sometimes we also do workshops and classes. And I work in the European region, so Europe, sometimes East of Europe and Africa as well. So today I want to talk to you about scripting of timeline. So timeline is the new feature that Unity introduced in 2017.1, so the version that just came out in July. I'm going to talk to you about timeline and, as I said, scripting of timeline. So this is a bit of a technical talk, but it might be also interesting for artists, because then you can go back to your team and talk with the programmer and say, dude, I saw some cool stuff that you need to check out. So it's I think it's a presentation that can be appreciated by anyone. So we introduced timeline. So what is timeline? Timeline is this tool that allows you to, it's very blurry, but trust me. It allows you to sequence things in a linear fashion. So you can sequence animations, you can sequence sound, video, clips. You can sequence camera shots with the help of another feature that we introduced recently, Cinema Machine. And you can even sequence other timelines, and you can sequence other stuff, which is mostly what I'm going to talk about today. So the question is timeline a purely linear sequencing tool? Yes, but there are some ways to use it in a different way. So especially, I mean, if you look at timeline, you look at a tool and you imagine movies, right? You see cutscenes, you see like something linear that plays from start to finish. But I guess, I don't know what do you work on, but I used to make games, so I love non-linear experiences. So for this demo, I'm going to use an RTS game, a real-time strategy. And I'm going to show you that basically with timeline, if we script timeline a little bit, we can do so much more than just play a timeline from start to finish, you know, something like predetermined. So, a brief introduction to timeline. Who knows about timeline? Okay, who has used it? Okay, so I'm just going to give a brief introduction to timeline. If you look at the tracks that we have in timeline, this is the anatomy of the track. So, you know, each track is like a line, and on the left you have basically the head of the track, which also defines the binding. So each track is connected to an object in the scene, is controlling that object. In this case, this track is bound to a camera, so this is a Cinema Machine track. And then on the right you have the clips, and you can have as many as you want, and sometimes you can also blend them together. So as you see here, in this case, these two clips, Storm VCAP and Freelook, are blended in the middle. So when you overimpose the clips, they blend together. So let's see an example in the editor, right? I'm going to go in the editor. This is the demo that I'm going to use. It's, as I said, it's a small RTS game. This is how it looks like. So if I want to create a very, very simple timeline just to demonstrate how to create one, usually you start with an object. So I'm creating an empty object. It's kind of hard to see, but yeah. I'm going to call it timeline, right? Timeline player. And the timeline uses a component which is called playable director, and then the component asks you for an asset. So I need to create a new timeline, and I create the timeline here in the project, and I'm going to call it IT demo, and then I can assign it to the newly created object. So the timeline is here, and now as I select this object here, I'm looking at the timeline. So for now there's no tracks. I can also lock the view, and I can add tracks. And as I said, there's a few things that you can do by default: activation, animation, audio control, and playable. Cinema Machine is also kind of included by default, and then there's more stuff that you can create. So for instance, if I create an animation track, we have here a nice test subject, which is our going to help us today. This character, and the character has an animator. So he has some behavior that he's going to play at runtime. But through the timeline, then I can, first I have to connect it, and then I can add animation clips. So if I add from an animation clip, then I can take from any animation clip in the project, provided it's compatible with this character. So for instance, I can use this one, medium scene A, and then here I have the animation. So here it's just going here and checking what's happening. And then once you create these clips, you can, set the duration, you can loop them several times, and as I said, you can always blend them together. So just by overlapping them. Another example is we can have control tracks, and control tracks allow us to control pliable assets. So for instance, in this case I'm going to use the torch, and if I connect this torch to the clip, so select the clip and then connect the torch. Now through the timeline I'm controlling its particles. So if I select the clip and here I say control particles, then as I scrub the timeline I can see the particles. So of course, and there's also the guy blending back to the initial position of the animation. It's a very poorly made animation. So one of the most important features of the timeline is this ability to be able to preview even if the game is not in play mode. Because of course if I press play, this timeline is going to play. Okay? So now it's playing in play mode, of course. But one of the most important features is I need to be able to preview what's happening here, even without pressing play. Because this timeline might happen later in the game, so I might have a long level, I might have a timeline that plays only when I arrive at, fighting and maybe defeating the boss, and I don't want to spend 2, 3, 5, 10 minutes every time I want to check the timeline. I need to test it in real time here in the editor. So in the editor you have this feature, you have this preview mode. If I, preview is deselected, I'm not looking at the timeline, and as I press preview, I'm actually seeing the timeline. The only thing you can't preview right now is, unfortunately, audio. So if I add an audio track and I add clips, you can't really preview them here, but Unity is working on this feature. So they're working on adding audio support in the editor, because of course it's really useful to be able to also listen to audio, because one of the main features of the timeline is putting things in sync. So I need to be able to, listen to the audio and see when a specific audio cue comes, and then I can sync my animation to that specific frame. So arguably one of the most important features. So this was a very, very brief introduction of timeline. And then, if I just disable the timeline, then nothing happens. If I press play on the thing, disable the torch as well. So we have a bunch of default tracks. So we've seen an animation track, we've seen the control track, and the audio. But as I said, we can add so much more by scripting. So we can create, and then another thing that you can quickly do is, so let me talk about the custom tracks first. So as I said, we have this bunch of default ones, and then we can create custom ones. So usually custom tracks require 4 different scripts: the track script, the clip script, the behavior script, and a mixed behavior script. And then optionally, you can also have a custom inspector if you want to customize how the clips appear in the inspector. So if we look at the tracks now from a programming point of view, how many programmers are here? Okay. I can speak your language. So if we look at the from a programming point of view, these 4 scripts that I mentioned, they mirror somehow what you see in the editor. So the first one, the track, defines the binding. The second one, the clip, works together with the behavior, and the clip holds the data from every clip, and then the behavior holds the logic. So if I create a clip that takes some kind of float, the float is going to be in the clip script, and then as the timeline plays, it's going to ask the behavior script. It's like, how do you function? What do you do? And then the behavior script is going to take the data, process it, and send it to the track, and say like, here's the output, do something with it. And then the track speaks with the bound object and says like, here's my output, right? Yeah, question.
This behavior script extends behavior script from Unity, right?
Not the default one. I'm going to show an example.
Unity has one behavior and behavior. This behavior extends from behavior?
It extends from another one. I think it's a playable behavior. I'm going to show it right now. No, it's not the default mono behavior that you apply on objects. So all of the stuff that happens in the timeline extends from the playables API, which is also the same API that powers the animator. So they are very similar. Underneath, they are very similar. The last script is the mixer behavior, and the mixer behavior is very similar to the number 3, the behavior logic. The only thing it does the mixing. So when you overlap clips, if they blend together, then the mixer behavior is the one that sits on top, and it goes like, okay, you do this, give me the data, I blend it together, and I create the output. But you can also not have the mixer. If you don't want to have blending, then you can ignore this one. So just to give you a quick example, right? So let's go back to Unity. I have this timeline here, and as I said, let me delete the audio track. So one very easy way to create custom clips is to use this one, the playable track. So the playable track, if you add it, it's empty and it doesn't really, well, there is one that I will create, but playable track is a generic track that accepts custom clips. So for instance, I created one, a very simple custom clip. It's in scripts, simple clip here. So these two scripts, mono-behavior and mono-developer, that's what they look like. So, sorry. As I said before, very simple example, this one is only clip and behavior. Clip and behavior. So clip extends from playable asset, simple behavior extends from playable behavior. So as you can see, they have some kind of generic code that you always need to have. Let me make it bigger. So the clip right now has no behavior in here. It just creates the playable and it just defines what's the kind of blending that I can have. And the behavior, sorry, the clip, no behavior and no data. And the behavior has no logic. The only thing it has is a float. So what I can do here is I can add, for instance, let's say I wanna make a clip that slows down time, right? So I will create a variable, a float, and then what I can do is I can override one of the main functions that playable behavior has, such as process frame. It's the most important one. And process frame is the one that happens every time the timeline is moving. Sorry, I'm jumping from. So in process frame, say again?
Is it like update?
So it's similar to update. It happens every time the frame moves. So in timeline, in the table directory, you can decide how the timeline is updated. So in this case, this timeline is updated, on update. So this behavior will also play on update. But you can decide to update the timeline manually, for instance, and then the behavior only happens when you update the timeline. But yeah, for now it happens like very similar to the to update. So in this case, I'm processing the frame, and here I'm going to do a very simple thing. I'm going to say or let's call it desire times A, right? So we don't confuse ourselves. So now in this clip, in this behavior, I defined a simple float. And then every frame, I'm just setting the time scale to that value. What does it mean? It means that in here, on the playable track, if I just create, it's compiling, so you see now I can add a clip and I can add my simple clip, the one I just created. And if I add it, it looks like this, it looks like a normal timeline clip. And if I select it, here I have the variable that I just created. So here I can say I want a 0.4, and then I want to bring it back to 1. So I have two clips now, 0.4 and 1, and as I play through this timeline, actually as soon as I click on this preview button, the time scale is going to be modified. So if I go to time, you see it's already on 0.4, so if I scrub through, it changes between 0.4 and 1, which means that I can do something like this. I start from 1, I go to 0.4, and then I go to 1 again. So if I play this timeline, this very poor timeline, actually, sorry, the guy is disabled. Let's enable him. Time scale is 1, and then time slows down. Maybe not the best example. And then it goes back to 1. But I mean, you know what I mean. This is a very, very, very simple example of what you can do with timeline. So you can create slow motion effects. And the interesting thing is that rather than having to play with times in a script, so you say like I want slow motion to happen at the 5th second, you can just create a clip, and then if you happen to change the timeline by moving these clips around, then you can just move this clip longer, and everything is fine and everything works again. So you are giving power to whoever is creating the timeline to be able to be faster, right, in the production of these cutscenes, because they don't have to mess around with the script. I mean, until now, when you created some kind of cutscenes, how did you do it? Mostly it's like a script that says like at this specific point in time, time scale goes to 1, and then at this specific point in time it goes to something, right? Sometimes people used to use in the animation window, they put like animation events that you can move on the timeline, but that's specific to one animation clip. Now you can sequence more animation clips and also create your own behavior. So as you can see, it's quite easy to just create a simple clip that goes on here. And this playable track, because it's the one that is default from Unity, I mean these ones are the default ones, 1, 2, 3, 4, and 5. This is just a group, so if I create it as just a way to group tracks together, see, and then I can collapse the thing. So these are the default ones, and this one, the one that I just showed you, basically accepts every kind of clip as long as they inherit from this one. Okay? But then, when you really see the bigger power of the timeline, let me disable this timeline here, is when you create your own custom tracks. But when you create your own custom tracks, then you need all 4 of these scripts. So let's see an example. Again, like we want to create one script for track binding, one script for the clip, one script for the behavior, and one script for the mixer. So here I'm going to show you basically 3 different examples. I'm going to start from this one. Okay, so now I'm looking at through the eyes of another camera which is black and white, and this is the timeline I'm going to look at. Let me get some more space for the timeline. Okay, so this timeline here has a track that controls the camera, so it has a bunch of shots using Cinema Machine. Then it has a bunch of dialogues, so it has a group for dialogues and it has a group for character animations. Character animation is just animation clips and some animation keys. So let's watch the timeline first. Let's put it to maximize. I press play. I have this animation, I have a camera movement that goes up, wide shot, and then we see the character from nearby, and we have the dialogue, and as you can see the timeline is stopped. So the timeline is paused, but of course the action still goes on, because the timeline is not, it's not a cutscene in a traditional sense. It's not a video. The timeline is just telling objects in the scene to move, to play and stuff like that. But the game is still running. So now the timeline is stopped, and what I need to do is I press the space bar, and I go on in the dialogue. So he's calling the other watch, and the dialogue waits for my input to play. So I can press space bar again, and then the dialogue continues, and she replies. She says, I haven't seen even a rabbit or something, this is very boring, and it waits again, and then I press space bar, and then I can go on in the timeline. And then there's like a classic final sequence where we see this monster in the sky that they haven't noticed, which is actually looking from above. So what have I done here? I've created a timeline that stops when the characters speak, waits for the user input, waits for the user to press the spacebar, and then it proceeds. Right? So if we look at the timeline, the key is basically here in the dialogues. I've created this custom time machine track, and what the time machine track does is when I play the dialogues, it stops the track here, and then it waits for user input. So as you can see, this is a proper custom track that I've created, and it has custom clips, and the clips even have a custom inspector. So here I'm able to decide some kind of action, and for now I'm just going to focus on the pause action. So I'm just creating pause clips. As you can see, if I change the type to a marker, even the name of the clip changes. So if I put it on pause, I clearly see here that this is a pause. It's a very simple trick. I'm just naming the clip as with two like pipe symbols. Right? So as the timeline gets here, it will pause, and I'm going to show you the code very briefly. So if I look at this track, it's called Time Machine. As I said before, 4 scripts plus a custom editor. So these 4 scripts, if I look at the track, it's a bit long. That's how it looks like. It inherits from track assets, and then it allows me to say, this track here accepts this kind of clips. So on this track, I'm only going to be able to place this kind of clips. And then I can even give a color for the track. I made it purple. And then there's a bunch of functions that you always have to call, like create track mixer. And in this case, this function names the clips at the beginning depending on their type. Yeah, that's mostly what it does. So if we look at the clips, as I said, the clips, they hold the data. So in this case, this clip holds the actions, conditions, marker label. The most important one that we're looking at here is the action type, which is here. And again, like some boilerplate code. And then I've put the behavior in the mixer. So the mixer, when it processes the frames, it checks which one is the type of action of this clip, and if this clip is a pause clip, then it just tells my game manager to pause the game. And if you see the code in the game manager, it's only doing this. So it's pausing the current timeline and waiting for the input. So this way I can quickly, create more dialogues. If I want another dialogue here, I can always create new clips here, and then I put a pause, and the timer will pause and wait for the user input. So the important thing here is that if I want to move this dialogue a bit forward, then I can just do this, and everything will be moved, and I don't need to sync the pause with the new dialogue. So when you create these new tracks, as you can see, there's a lot of code that you have to add. In the beginning, especially the track that you need to add this function every time, it can be a bit complicated. So Unity has released a thing called Timeline Playable Wizard. You can find it in the store. It's called you look on the asset store, it's called like this, like default variables, and it contains this tool, which is a wizard. If you open the wizard, that's how it looks like, and this tool basically helps you create new tracks. So when I created these tracks, these custom tracks, I didn't start from scratch. I didn't open a new file and start to code because it's quite complicated. So I used this wizard to create the 4 scripts for me, and then I customized them. So this wizard, what it does is it allows you to create, for instance, I want to create transform track. Actually, let's go just transform transformer. I can say it's a standard kind of playable, and then it asks me which object I want to bind. So basically, by using this feature, I'm able to create a track such as this, and it asks me which object to bind, so it will ask me which object do I want to bind here, and then I can add variables. For instance, I can add position, and I can give it a color, the classic magenta color. So once by using this wizard, then I can create it's compiling. Here it is. So I have the 4 scripts, track, clip and behavior, and mixer behavior, and then also the editor script. And now I can just use this track normally in any timeline. So if I go back to the previous one, our test timeline, now here I can use this track. It's here in the custom ones, and I can add it. It's here, it has the color that I decided, and as you can see, I decided to use a transform as the binding type, and now I can select the transform, and then here I can add clips, and once I select clip, here I have the position, which is the property that I selected in the wizard. So the wizard basically does all the job for you. It creates the 4 scripts, and it asks you which object do you want to bind them to, and which properties do you want to control. And because it creates the mixer, I can also create tracks, more clips, and mix them together. So if for example, if I have this character at place here, to local timeline, it is at 0, 0, 0 on the first clip. On the second clip, I can say that it's 3, 3. Let me use these tracks. Let me use the time track as well. So now I'm looking only at the position, and as you can see, it blends between the positions. So in the blending here, it blends between 0, 0, 0 and 3, 0, 3. So the wizard creates all the scripts for you, and then you can just go in, select the scripts and modify them, and start building your own stuff. Is it clear? This part, I know it's a lot of, it's quite complicated. So did you understand the relationship between the 4 scripts?
Yeah.
Track defines the binding, it's here. Clip defines the data, behavior defines the logic, and then if you want to mix them together, you need to have a mixer behavior that looks at all the inputs, takes all the data, crunches it and sends it to the track, which will send it to the object. So there's this flow of information through the timeline. In the example that I gave before, the one I called simple clip, the one that changes time, there's no mixing. Now if I look at the clips again, custom, simple clip, you see I only have these 2 clips, there's no mixing. There's only one processing when the playhead hits the clip. This script is going to say, okay, what's the desired timescale? Just use that timescale and that's it. And actually this is also a very poorly optimized script, because when I process the frame, it means that I'm doing it every frame, So I'm setting the time scale every frame, which is useless. I should just do it once when I hit the clip. So this is just a simple example, but then you can do so much more. So you can set some kind of Boolean variable, let's say time already set, and so you don't do the operation every frame. So this is just a very simple one operation script. Let me clean this timeline. So yeah, through this wizard, you're able to create many types of tracks. You can decide even if they have, as you can see, if they can support looping, if they support blending, if they support all of them, or if they support none. So if you say that they support none, there's going to be no blending between the tracks. So just to go back to presentation, so this is how you create custom tracks. Now, we've seen a timeline, we've seen a custom track that allows me to pause the timeline, right? But the timeline is still linear, so I still start from beginning to end. I just pause on the way, and then I resume whenever I want. But you can also create non-linear timelines. So timelines that play, and then maybe they go back, and they go back again, and maybe then they just resume and they finish. In this case, I'm basically saying the timeline is looking at the game logic from the game, is checking something, and if that something happens, it rewinds. And the timeline is producing the animation, the final animation, but it's just taking info from the game logic from the game. So if I go back to Unity, I'm going to show you this storm timeline. Sorry, I want to just show you the game very quickly. So this is the game. It's not really a game, it's just a quick demo. I can move the camera around, I can select these units, I can move them around as a platoon, right? So I have a bunch of units. They all have an animator that controls their animations. Then they have a nav mesh agent that controls their movement around. And then they have a script, which is called it's here, it's called unit. It's a script that I wrote, which is some kind of AI. So the unit script just sends, receives a command from the input, like for instance, go here, and then it says to the nav mesh agent, go there, and it triggers that specific animation and so forth. Yes?
They form a circle all the time.
Yeah.
Is it a feature or a...
It is. So if I send just 3 units, they form a triangle. If I send 4, they like square. I program the position, so when I send them to somewhere, I calculate like different points and I send them there. I send the nav mesh agent there, and then the nav mesh agent finds the path. And then they can also attack enemies. So here I have some enemies. They're here. If I click this guy, and they will all go and attack him. Start attacking, the enemies react. So there's some kind of AI, right? So this is the base game. Yes. So I'm attacking these units, blah, blah, blah. And this is the game. Let's go back. Now I want to create a timeline that does something that interacts with the game. So I created this storm timeline. Now this storm timeline has, as you can see from the track, some camera, and it deactivates the input at some point, and then it has some extra tracks for lights, extra tracks for the rain, extra tracks for some lightning strikes. So if I play this track, I press play, the camera changes to this view, it starts raining, and then I start seeing some lightning strikes. The light does these like flashes, and then I can play. So now I'm playing, and I can select my units, and it's raining. So there is a timeline that's playing, and now the peculiar thing is the timeline will rewind infinitely until I kill these 2 guys. So suppose they are like the final units, like there's a big battle, and I have to kill all these monsters. And then I have this store that plays all the time, as long as the monsters are alive. Okay, this is sorry. The track is deactivated. I know why. So the time machine track is muted, that's why it doesn't do it. But if I show you the, let's not maximize. So if I show you this, and I think I can even like fast forward. So I'm looking at the game now, I'm playing the game. You see the clip here? You see it goes back? So if I'm here in the timeline and I play, and these guys are not dead, this clip will send the timeline here, to this other clip. You see? As soon as I kill these guys, well, not as soon as but if I kill these guys.
Is it possible to make it as soon as you kill these guys?
Yeah, but I didn't do it. You can. Yeah, you can. I'll talk about this later. You can do it. So you see now the timeline finishes. I mean, it exits, let's say, and it stops raining. The light goes back, and now I'm back again in the game, and it's good weather again. So what's the message here? That you can create timelines that are not only linear, but they can wrap around depending on some conditions. So the time machine track, the one I showed before, and before I showed it just for the pause, it actually supports more things. So if I select these clips here, this clip, instead of being a pause, is a jump to marker. And I say, you need to jump to this marker. So this one is actually a marker, and it's named like this. So if you go back to the code, which, as I said, is kind of a complicated code, if the clip is a jump to marker or jump to time, it just looks for the specific marker, but before doing that, it checks for a condition. Where is it? Lost it. This one. So it asks the clip, time machine clip. No, sorry, time machine behavior. Asks if a specific condition is met, and in this case, this clip is taking these monsters as an input, and it's asking the monsters, are you all dead? If you're dead, then I just let go and I finish. If you're not dead, then I will wrap, and I will wrap to this specific marker. So as I go here, condition is verified. If it's false, then I go back to this one. Okay? And it will do it every time until it's true, and then it exits. So there is some kind of logic in the timeline that makes the timeline non-linear. Right? It's some kind of branching. You might even think of having the timeline jump to another section, so you can have, quick time events, for instance. So the timeline shows you an animation, and then as you get to the specific clip, if you press A in time, and you jump to the success, and if you don't, then you go to the failure. So you can sequence like 2 animations and just use it for that. But I would say don't do that for quick time events, because that might become like a complicated timeline to manage. At that point, it's better to have more timelines, right? But in this case, you can have something that plays in the background and just stop it when you want it to finish. But in addition to stop it, you also have an ending animation. So all of this stuff can be done, by some artist person. They just sequence the lighting, they sequence the particles, they sequence these lightning strikes, and they decide, the artistic part. And then by just using these clips, they can also decide when it wraps. As you can see here, I also created a track, I call it fast forward. It's doing exactly the same thing, it's just jumping forward. So if I press play here, this clip is going to fast forward here. This was actually the thing to demo it faster. So if I go here, this one will jump to the other one, and then I see it wrap around. And this one is just the same as before, it's a clip that jumps to marker. The only thing is here is not verifying any condition, it's just doing it always. But then we can do even more. So this track that I showed you just asks for a Boolean value. It says true or false. But we can plug the whole timeline into the game systems. So in this game, I have one very important system, which is the AI of the game. The units, they receive commands and they go somewhere. If they see enemies in range, they attack the enemy. So they can receive a command to attack the enemy, or they can receive a command to stop. So I can plug the timeline into this game AI, so I can have a timeline that controls the AI, and then instead of having animation through the timeline, I have animation produced by the AI. So the fact that they move around, the fact that they play a specific animation is not done by the timeline, it's done by the AI. So back to Unity. If I enable this other timeline, which looks like this, let me play it first, so I'll show you what it's like. So we see some goblins, they're chasing the boy from the village. He's trying to escape. Then he tries to fight back, but dramatically, so he dies. So it's war. So our units now are going to attack the goblins who are invading the city, trying to invade the city. So there's a battle, but there's more goblins coming from here. Let's see who wins the battle. Actually, you can't control this battle, it's a proper cutscene. So yeah, the goblins have won the battle, and it's the end. And also have 5 minutes remaining, so this is a good time. So in this cutscene, what I'm doing is instead of animating the characters one by one, I'm plugging into the game AI and I'm sending commands to the unit. So I wrote another track, which is this one. It's called AI command track. What this track does is it takes so these are all AI command tracks. This is a clip. The track takes what I call a platoon. So platoons, if you look at the, for example, these ones, well, actually, let's look at this one, monsters. Platoons are very, very simple scripts. They contain a list of units, and they just propagate the commands. So if somebody gives a command to the platoon is going to give the command to all the units. That's exactly the same thing I do when I select the units. There's a selection platoon, and I say go there. The game manager will say to the selection platoon, tell your units. The platoon tells the units, and the units do it. So by having like this flow, right, I can then plug this flow into the timeline. So here I'm plugging the platoon into the track. Now, for example, this platoon of monsters, it's here, and it's just these 3 units. And then I can, through the clips, give them a command. I'm saying to the boy to just go and stand still, and I'm telling him to go to this position, so the boy goes there, and then I'm telling the monsters to attack the boy, and they will do it. And then, so they do it, and they kill the boy here, and then they go, sorry, let me give you some space here. The monsters go to the center of the scene here, they join these units here, and then the units also move and attack, and you have this other big platoon of monsters that comes from the back and just assembles there. And once they're there, they're going to just fight, because the AI will make them fight. So I don't need to sequence any animation of strike, heat, movement. I just say go there, and then they resolve the thing, right? But then through the camera, what I see it's a different action, and it looks like more cinematographic. So as you can see, just by using 4 tracks, I can sequence actions for like hundreds of units. I think I could have there hundreds of units, as long as my game supports them, right? Oh yeah, and then the other key thing on this track, which is very important, is these units are using the nav mesh agent. So the nav mesh agent is something that only works in play mode. So when I press play, they go there, right? But when I'm in edit mode, I have no way of previewing the thing. So for this specific track, I wrote the AI command to the mixer. When I process the frame, I make a distinction if the application is playing or is not playing. So if it's playing, I use this function here, which is this one, and I just tell the nav mesh agent to go there, right? But if it's not playing, I use this other function, and basically what I'm doing is let me go to game view. So for instance, for these units here, which is the platoon B, it's these monsters, I'm telling them to, let's take this clip here, right? They're here, I'm telling them to go here. What I'm doing in non-play mode, in edit mode, is I'm tweening the position manually. So I'm saying, you're here, your final position is here, calculate the formation, and then over the course of the clip, I tween the position. Which might not be the final position, because as the game is played, the AI might be somewhere else, but it gives me an approximation of where the units will be. So the key point here is I'm splitting the work into two, and I'm giving some kind of preview, because otherwise, if I didn't do this, then somebody who's editing this timeline wouldn't see, the effect, and they will lose basically the biggest advantage of timeline, which is to synchronize things in the editor. So they will need to play the timeline every time to preview what's happening, and we don't want that. And since I'm running out of time, I'm going back to this. So we've seen what we can do with timeline. We can do much more than just sequencing things. If you just script it a little bit, you can have custom and non-linear playback. You can slow down time. You can access anything you have in the Unity editor. And you can also, I haven't shown this, but you can also create clips dynamically. So if you have some kind of text file, you can read from the text file and then you distribute the clips dynamically. That's also possible. Or you can bind objects at runtime. So all the binding here, which is already done by me in the editor, you can do it through script. This is useful if you're using the timeline in a new scene. So if you have a scene that uses, you have a timeline that you use in different scenes, you can bind it dynamically. And then you can possibly export tracks and clips to data files if you want. So you make the timeline in Unity and then you export everything in a text file. There's a use for that. And more. So again, it's a bit complicated to script it, but if you look at the asset store for the default playables package, which is obviously script, it contains that wizard which should get you started. And then if you want, I can also give you this project to see what I've done. The code is all commented, so then you study it in depth and you can start scripting the timeline.